Yeah, hello everyone. So this is a question from JEE Mains 2026-28 Jan evening. The correct increasing order of spin-only magnetic moment. Okay, spin-only magnetic moment. Values of the complex. So they have given us some complexes. So A, B, C, and D, and we have to calculate their spin-only magnetic moment, and we have to arrange them in a order. So these are the options. Okay. So the chapters involved is coordination compounds, and before we start, we should know that spin only magnetic moment is calculated by the formula root of n plus 2 bm, where bm is Bohr magneton. And so you can see here that spin only magnetic moment is directly proportional to n. So more is the number of n, more is the value of spin only magnetic moment. And what is n? N is the number of unpaired electrons. So technically, you can either calculate using this formula for all the four complexes, which is going to take you more time, or you can calculate their n. So bigger is the value of n, higher will be the value of magnetic moment. Okay, so let's take these complexes one by one. So A is MnBr4 2 minus. Okay, A is MnBr4 2 minus. Okay, to calculate the magnetic moment, first we have to know the oxidation state of the central metal atom, that is Mn. Okay, so assume it as X. We know that bromine exists as the ligand is Br minus. So 4 into minus 1, and the total charge in the complex is 2 minus. So therefore it will be equal to minus 2. So X is equal to minus 2 plus 4, that is plus 2. So the oxidation state of manganese is plus 2. Okay, so manganese, so let's see the electronic configuration. Manganese, we know in ground state is 3d5 4s2. So manganese in the plus 2 state will be, so remove the electrons from the outermost shell. So this is the outermost shell. So remove 2 electrons from there. So we are left with 3d5. Now, what is the ligand here? The ligand is Br minus. Okay, and it is so Br minus, it is a weak field ligand. So therefore it cannot cause any pairing. So therefore no pairing happens, and hence these 5 electrons will be present as it is. There will be no pairing. So therefore 1 2 3 4 5. So 1 2 3 4 5, there is no pairing here. So this is the 3d orbital. So extra information, Br, there are 4 Br minus, and 1 contributes 2 electrons. So therefore 4 will contribute 8 electrons. So there are total 8 electrons which are to be accommodated in free orbitals. So therefore those free orbitals are, after 3d we have 4s, then we have 4p, right? So those 8 electrons are coming here, 1 2 3 4 5 6 7 8. Okay, so this is where they are going. So the hybridization of extra information, MnBr4 2 minus will be sp3, because 1s and there are 3p, so sp3. Okay, so coming back, so we can clearly see here n value is 5. Okay, so the value of n is 5. So let us write it down here. For this, n value is 5. Okay, next we have the second complex, that is CuH2O 6 2 plus. Again, let's calculate the oxidation state of copper in this particular complex. So X plus 6 into 0, because water doesn't carry any charge, so it will be equal to plus 2. So X is equal to plus 2. Okay, we know copper in ground state is 3d10 4s1. We have to remove 2 electrons. So 1 electron should be removed from here, another one should be removed from 3d10. So therefore the configuration of copper in plus 2 state will be 3d9. Okay, and the next thing is H2O. H2O is again a weak field ligand. So therefore there will be no pairing. So therefore if we look at the configuration, 1 2 3 4. So 1 2 3 4 5 6 7 8 9. So therefore there is 1 electron which is unpaired. So n value is going to be 1. Okay, so for this particular complex, the value of n is 1. So let us write it down. For this guy, n is equal to 1. Then let's calculate for complex C. Complex C is NiCN 4 2 minus. Okay, so again assume the oxidation state of Ni to be X. We know Cn exists as Cn minus. X plus 4 into minus 1 is equal to minus 2. So X is equal to minus 2 plus 4, that is plus 2. So therefore the oxidation state of Ni is plus 2. Okay, we know that nickel in ground state configuration is 3D8 4s2. So nickel in plus 2 state will be 3D8. Okay, and here the ligand is Cn minus, which is a strong field ligand. Okay, so therefore there will be pairing, it will cause pairing. Okay, so let us see 3D8 without pairing first. So 1 2 3 4. So 1 2 3 4 5 6 7 8. Now because of the presence of a strong field ligand, these two guys are gonna pair up. Okay, so therefore the new, so after pairing, nickel plus 2 is gonna look like this: 1 2 3 4. So 1 2 3 4 5 6 7 8. So therefore there is pairing. Okay, and since there are 4 Cn minus, so 1 Cn minus contributes 2 electrons, so 4 Cn minus will give us 8 electrons. So the rest of the 8 electrons are going to get filled in these empty orbitals. So 2 here, 3 4 5 6 7 8. So therefore the hybridization is dsp2. Therefore this is a square planar complex. Okay, extra information. So after pairing you can see there is no unpaired electron, so n is going to be 0. So therefore we can write it down that in the third complex n value is 0. Okay, now let's calculate for the fourth one. The fourth complex is NiH2O 6 2 plus. Okay, so again let's calculate the oxidation state of nickel. Assume it as X plus 6. We know water it is 0 plus 2, so X is going to be plus 2. So we know nickel in ground state is 3D8 4s2. So nickel in plus 2 will be 3D8. This time the ligand is H2O. So H2O is a weak field ligand. So therefore there is no pairing. And since there is no pairing, the situation of nickel will look like this: 1 2 3 4. 1 2 3 4 5 6 7 8. So since there is no pairing, so these two guys, they are not gonna pair up like the previous case. Okay, so now there are 6 H2O. One H2O contributes 2 electrons, so 6 will contribute 12. So we have, so the ligands are going to contribute 12 electrons. So therefore S, so we have 3D, then we have 4s, then we have 4p, then we have 4d. So the rest of the 12 electrons will be accommodated here: 1 2 3 4 5 6 7 8 9 10 11 12. So therefore the hybridization is sp3d2, sp3d2. So therefore it is an octahedral complex. Okay, so that's a different story. Now here can you see that there are 2 unpaired electrons, so n is equal to 2 in this case. Okay, so n is equal to 2 in this case. So therefore we can clearly see the maximum spin only magnetic moment will be of crystal A will be maximum. Then we will have D, because D has 2. Then we will have B, and then in the end we will have C, because it has 0 unpaired electrons. So this is the answer, this is the order. So which option is matching that? A, D, B, C. Yeah, so C is the correct answer. C is the correct answer because A is maximum, then D, then B, then C. Okay, thank you.